In the previous video, you learned how to solve systems of equations by using the addition or subtraction method. Now with that method, it is good when you can get things to cancel out. Alright, but there's times when maybe things will not cancel out right away, and so I need to incorporate multiplication with the addition or subtraction method. So let's look at some examples. Example 1. If you had these two equations, x minus 2y equals 6 and 4x plus 3y equals 2. If you're to try the addition or subtraction method right now, notice if I add or subtract, nothing will cancel out, right? Because we have, with the x's, we have 1x and 4x. Those are not the same number. For y's, we have negative 2 and 3. Those are not the same number either. So if I add or subtract, nothing cancels. So what I need to do is multiply first so that the equations will cancel when I add or subtract. So what I want to do is look at either x or y and determine what would I need to multiply either equation by to get something to cancel. Well, look here at this first equation. If I can get this x to become a 4x, for example, then they would cancel by subtracting, right? 4x minus 4x would cancel out. So what I want to do is make this into a 4x, and I do that by multiplying the entire top equation by 4. So I have 4 times x, but also I have 4 times negative 2y and 4 times 6. So if I do that, I'm going to have 4x. 4 times negative 2 is negative 8, and 4 times 6 is 24. And now at this point, the 4x's could cancel with subtraction. So I subtract both equations from each other. 4x minus 4x would cancel out. Subtract everything else as well. Negative 8 minus 3 is negative 11y, and 24 minus 2 is 22. So the x's are canceled. I have one variable, and from here I can solve by dividing both sides by negative 11. When I divide, I have positive y equals negative 2. And then to finish off, I need to solve either equation for x to find what x is. If I pick the first equation right here, so without the 4, just the x minus 2y equals 6, looking right here, I can plug a negative 2 for y. So if x minus 2 times negative 2 equals 6. Well, negative 2 times negative 2, that becomes a positive 4. So I have x plus 4 equals 6. Subtract 4 from both sides. I have x equals 2. So my solution is x equals 2 and y is negative 2, which I can write as an ordered pair to get 2 comma negative 2. And by the way, I can always check my solution by plugging back in to both equations to make sure that we get true statements back out. So if you were to check your solution with the first equation, you have x minus 2y equals 6, plug a 2 in for x, and a negative 2 for y. So 2 minus 2 times negative 2 equals 6. So then negative 2 times negative 2 is plus 4, so 2 plus 4 equals 6. That is a true statement. So the first equation is good. Check the second equation, 4x plus 3y equals 2. Plug a 2 in for x and a negative 2 for y. So now I have 4 times 2 plus 3 times negative 2 equals 2. So this is going to be 8, and then minus 6 equals 2, which is a true statement. So therefore, we do have the correct solution. And graphically speaking, if you were to put this on the graph, notice they cross right here at this point, which would be 2 comma negative 2. So we have found the correct solution, and that is where the two lines will intersect. Let's look at 2 more examples. Next we have 3x plus 4y equals 6, and 2x plus 3y equals 5. Alright, this one is more difficult than example 1 because notice that nothing cancels right away, so just like the first one, right? X's, we have 3 and 2. If I add or subtract, nothing cancels. For y, we have 4 and 3. If I try to add or subtract, nothing will cancel. And even if I try to multiply just one equation by something, they won't cancel either, because looking at the x's, if I try to get the 2 to become a 3, 2 times what gives me 3? Well, it's going to be a fraction, right? Which we don't want fractions, so that doesn't work. The y, 3 to 4, to get the 3 to become a 4, I would also have to multiply by a fraction, which we don't want. So this is more difficult because what we need to do is actually multiply both equations by a number. Alright, so if I choose the x's, for example, I see we have the number 3 and the number 2. What I can do is I can find, well, I guess I can multiply both equations by something. And maybe the easiest way would be look at this 2 here, multiply the top equation by the 2, and the bottom equation by this 3. That could be the easiest way to do this. It's not the only way. You can multiply by other numbers as long as the two equations become the same for x. Alright, so if I do it this way, we have 2 times the entire top equation. So we'd have 6x plus 8y equals 12. And then 3 times the entire bottom equation, we would have 6x plus 9y equals 15. So now notice the x's are the same number. They're both 6. So what that means is I can subtract them right away, right? 6 minus 6, that would cancel. And now we can solve for y. So the x's cancel. For y, we have 8 minus 9y, which gives me negative 1y. And then 12 minus 15 is negative 3. So negative y is negative 3, which means positive y would be positive 3. So I've solved for y, and I can use this to find x. Plug this back into either equation, doesn't matter which one, we'll choose the first one. And so we do 3x plus 4 times 3 equals 6. Well, 4 times 3 is 12. Solve by subtracting 12. We now have 3x equals negative 6. And then divide by 3. We now have x equals negative 2. So x is negative 2 when y is 3. I can put it together as an ordered pair to get negative 2, comma 3. And if I wanted to check my solution, I can, and I do that by plugging back into both equations. So up here, the 3x plus 4y equals 6, plug in negative 2 for x and a 3 for y. We now have 3 times negative 2 plus 4 times 3 equals 6. So 3 times negative 2 is 6, 4 times 3 is 12, so negative 6 plus 12 gives me positive 6. So this is a true statement, which means it works for the first equation. I can plug it into my second equation to confirm that it works there as well. So plug in negative 2 for x, a 3 for y, to get 2 times negative 2 plus 3 times 3 equals 5. 2 times negative 2 is negative 4 plus 9 equals 5. So we have 5 equals 5, which is a true statement. So we have confirmed that we did find the correct answer of negative 2, comma 3. And graphically speaking, we would get these two lines, and they would intersect right here at this point, negative 2, comma 3. Now looking back at the initial question, we chose initially to get the x's to cancel by multiplying the top by 2 and the bottom by 3. I could have done the y's as well. So looking here at the y's, I can try to get these to cancel if I would rather. And to do that, I see the 4 and the 3. If I multiply the top equation by the 3 and the bottom equation by the 4, then we would get 9x plus 12y equals 18, and then 8x plus 12y equals 4 times 5 is 20. If I went this route, notice now the y's could cancel, and when I subtract 12 minus 12, that cancels out. Then we have 9x minus 8x, which gives me 1x, equals 18 minus 20, which is negative 2. Then plug that back in for x. We could have gotten 3 times, for the first equation, 3 times negative 2 plus 4y equals 6. So negative 6 plus 4y equals 6. I can solve by adding 6. We now have 4y equals 12, and then divide by 4 to get y equals 3. Notice my answer is still negative 2 comma 3. So it does not matter which variable I choose to get to cancel. As long as you do it correctly, you'll get the same answer back out. Let's take a look at one more example. Here we have 3x over 4 plus y equals 4. And on the bottom, we have x plus y over 3 equals 9 over 2. This one just looks bad because of all the fractions. And what I like to do is first, before I try to get anything to cancel or multiply to get the variables to cross out, what I want to do is get rid of the fractions. Alright, so look at the first equation right here. For both equations, I want to multiply everything by the least common denominator. So for the first equation, the only denominator is 4. So if I multiply everything by 4, then I will get the fraction gone. So I do 4 times everything. So 4 times 3x over 4. If I do that, the 4's would cancel and I'm left with 3x. Alright, and then 4 times y is 4y. And then 4 times 4 is 16. So multiply every term on both sides by 4. Second equation, I see the denominator of 3 and 2. So the least common denominator is going to be 6. So I multiply everything by 6. So 6 times x would be 6x. 6 times y over 3. Let's do that over here quick. 6 times y over 3. The 6 and the 3 can divide out. Divide both by 3. We get 2 over 1. So that gives me 2 times y, which is 2y. And then 9 over 2, multiply by 6 as well. So 6 times 9 over 2. The 6 divided by 2 would give me 3 over 1, which would give me 27. It's 27. Alright, so on the right side, we get 27 over here. Alright, so my two equations we see typed up right here. And at this point, we can try to get things to cancel. So as we stated in example 2, okay, we want to get either x or y to cancel. It doesn't matter which one. But at the moment, nothing will cancel. Right? If I try to add these together, 3 plus 6 is 9. That doesn't cancel. If I subtract, we get negative 3. That doesn't work. With the y's, 4 plus 2 is 6. 4 minus 2 is 2. If I try to add or subtract, nothing will cancel and give me 0. So I need to multiply one or both equations by something. And in this case, it'll be a little bit nicer than example 2 because we only need to multiply one equation by something. So we can choose either x or y. We'll choose the x's just because. And notice here we have a 3x. Down here we have 6x. So I can make the 3 into a 6 by multiplying by 2. So multiply the top equation by 2. And when you multiply everything, you get 2 times 3x, which is 6x. 2 times 4 is 8y. And 2 times 16 is 32. So now look at the x's. We have the same number, 6 and 6, so I can subtract, and those would cancel. Right? 6 minus 6 is 0. Subtract everything else. We have 8 minus 2y, which gives me 6y. And 32 minus 27 is 5. So 6y is 5. I can solve by dividing by 6. We now have y equals 5 over 6. So at this point, I can plug in 5 over 6 to solve for x. I can choose any equation. It doesn't matter which one. And actually, I have 6 to choose from. Alright, so pick one that would be the easiest to work with. Now, no matter what we do, we're going to end up with some fractions. So let's just pick this first equation right here. we wouldn't want the first two before we multiplied because we would have even more fractions up here. So let's choose this one because there's no fractions. And so looking at that equation up here, 3x plus 4y equals 16, plug a 5, 6 in place of y. So now I have 4 times 5, 6. Well, 4, or 4 over 1, times 5 over 6. 4 and 6 both can be divided by 2. So that gives me 2 and 3. So then 2 times 5 on the top gives me 10. 1 times 3 on the bottom is 3. So we have 10 over 3. So then to solve for x, I need to subtract 10 over 3 from both sides. The 10 over 3's cancel. I have 3x equals 16 minus 10 over 3. Now to subtract 16 minus 10 over 3, I need a common denominator. Alright, so let's change 16, or 16 over 1, into something over 3. Well, 1 times 3 is 3, so 16 times 3 on the top gives me 48. So 48 minus 10 gives me 38. So I have 38 over 3. So 3x equals 38 over 3. And then to solve for x, I divide both sides by 3, which dividing by 3 is the same thing as multiplying by 1 over 3. So that's going to give me 38 times 1, or 38. And then 3 times 3 is 9. So my final answer is x equals 38 over 9, which I can write as a mixed number, which would be 4 and 2 ninths. Alright, 4 and 2 ninths. So putting it together, x is 4 and 2 ninths. So 4 and 2 ninths, and then y is 5 over 6, which if you were to find this on the graph, we would get this point right here. And notice with graphing, this would have been impossible to conclude if you were to do this by freehand. Alright, so this method is nicer because even though there's fractions, we can actually solve and get the exact answer. And that concludes our lesson for today. We will see you next time.